the mole. So the mole is the SI unit for amount of substance. A mole, abbreviated MOL, is the amount of a substance that contains as many particles as there are atoms in exactly 12 grams of carbon-12, the isotope. So Avogadro's number, 6.022 times 10 to the 23rd. We won't worry about the 1415. We'll stop it at 6.022 and then times 10 to the 23rd. Is the number of particles in exactly 1 mole of a pure substance. So, now molar mass. The molar mass of 1 mole of a pure substance is called the molar mass of that substance. Molar mass is usually written in units of grams per mole. The molar mass of an element is numerically equal to the atomic mass of the element in atomic mass units. So chemists use molar mass as a conversion factor in chemical calculations. For example, the molar mass of helium is 4 grams per 1 mole of helium. So to find how many grams of helium there are in 2 moles of helium, multiply by the molar mass. And we'll do a bunch of calculations momentarily to show you how to do this. So we start with our 2 moles, beginning value in the problem. Since we want to go to grams, grams need to be on top, moles need to be on the bottom, so the mole you can cancel out. And we get this number 4 from the periodic table. It is the mass number, or molar mass, of the element helium. So that's how we get 8 grams. So conversions with Avogadro's number. And like I said, this will make more sense when you see examples done. Avogadro's number can be used to find the number of atoms of an element from the amount in moles, or to find the amount of an element in moles from the number of atoms. In these calculations, Avogadro's number is expressed in units of atoms per mole. All right, so we're going to do a few examples here. So the first one says, what is the mass in grams of 3.50 moles of the element copper? When you're doing a mole to gram problem, unless they tell you otherwise, your mass is most likely going to be in grams. So we're going to start with what they give us in the problem, and they give us 3.50 moles of Cu. Okay? So now, we want to get to grams, so the gram unit will be on top. And we want to get rid of moles, so moles will be on the bottom, moles of Cu. Now, for right now, anytime we do a mole to gram, gram to mole, anything with mole conversions, when we're using our conversion factor, the only number that goes with the mole is the number 1 for right now. So we'll have 1 mole here. And the mass of copper on the periodic table, the atomic mass, Cu, is 63.55. So we'll put that up here. So now we put that in our calculator. And we get 3.50 times 63.55. And we get 222.43 grams of Cu. Okay, now the next one, we have 11.9 grams of aluminum. We want to go to moles of aluminum, right? So I told you before, the number 1 goes with moles right now, so 1 mole of Al. Now we want grams of Al on the bottom. Now we need the molar mass of aluminum, which is 26.98. So 11.9 divided by 26.98, and we get 0.44 moles of Al. So now if we look at both of these problems, and I'll put that decimal point a little better so you can see that. All right, so now if we look here, right, when we go from grams, when we go from and I erased everything. So if we notice in these problems, which I don't need the calculations there to go over this. So, but if we notice when we go from moles to grams, right? I like to think of it like this, right? You're going to have a big number or a molar mass in the numerator. So when you go from moles to grams, you're going to multiply. Still got to divide by 1, but it's going to be the same number, so you're going to have to multiply. Now we go from grams to moles. Even though you still have to multiply by 1, it's the same number. You will divide. All right, so moles to grams, multiply, grams to moles, divide. Now we can erase that for good. All right, so now a couple more examples. I think we're going to bring Avogadro's number in here, and we are. So it says how many moles of silver are in 3.01 times 10 to the 23rd atoms of silver. So we put down 3.01 times 10 to the 23rd atoms Ag. Okay, so now since we're dealing with just one single atoms of Ag, we're just going to go from atoms right to moles. So times 1 mole of Ag all over. When we're dealing with atoms and we need to use a conversion factor, we're going to use Avogadro's number. So 6.022 times 10 to the 23rd atoms Ag. So I do that, my calculator, 3.01 times 10 to the 23rd divided by 6.022 times 10 to the 23rd equals 0.50 moles of Ag. Now, once again, just to reiterate, very important, when we have atoms of a single element, all we need to do is go from atoms to moles. We'll learn later in the year when we have something with more than one atom, we'll have to use more steps, okay? So this problem, it says, what is the mass in grams of 1.2 times 10 to the 8th atoms of Cu? And we want to go to grams, okay? But I know for a fact I can't go right from atoms to grams. I need to go from atoms to moles first. So times 1 mole of Cu all over Avogadro's number. And then I can go to moles. And the molar mass of copper, Cu, would be 63.55. We should get around 1.27 times 10 to the negative 14th grams of Cu. I'll write that again. It's a little sloppy. And this concludes our video on mole calculations with single atoms.